We're in section 5.5, and our first rule is the quotient rule. The quotient rule says if you have a base to the m power and a base to the n power, and those have like bases, your rule is you subtract the exponents. So the rule actually says, if we look at our first example, which is x to the sixth divided by x to the second, our rule says that we subtract the exponents. So I'm going to say that's x to the 6 minus 2, which would give me x to the fourth in the top. Our second rule is the zero exponent rule, and it says any base to the zero power is 1 as long as that base itself is not 0. So our example for this rule says if we have 636 to the 0 power, that answer is 1. Our third rule for this section is the quotient to power rule, and it says if I have a fraction raised to the n power, then I'm going to get the numerator to the n power over the denominator to the n power. So my quick example for this one is x over 5 squared. So that would actually be x to the second over 5 to the second, which would be x squared over 25. Now we're ready to work our problems. Your directions for this section are to perform the indicated operations. My first two problems are x to the fifth over x to the third and x to the fifth over x to the ninth. Although the rule that the textbook uses is a great rule, I have a little bit of an easier way to work them. My way is this. I'm going to take the largest power and start there. So in my first problem, the largest power is 5. So I'm going to say that 5 minus 3 would give me an x squared left over. You're going to put that x squared wherever the larger one was. So since this 5 was larger, that means my x squared is going to go in the top. And the answer for this problem would be x squared. I don't want you to work it out this next way, but it does show you how the rule works. If you have an x to the fifth, that's 1, 2, 3, 4, 5 x's in the top. If you have an x to the third, that's 1, 2, 3 x's in the bottom. And so these x's cancel, these x's cancel, and these x's cancel, which leaves you with 2 x's left in the top. And that's how that would look visually. My second problem is x to the fifth divided by x to the ninth. Using my rule of working it, I'm going to take my largest exponent, which is 9, and I'm going to say 9 minus 5 would give me 4 x's. You're going to put those 4 x's wherever the larger one was. Since 9 was larger, that means the x to the fourth is going to go in the bottom. Since there is not a number in the top, that's understood to be a 1, and 1 is our placeholder. If you looked at this problem visually, you have 5 x's in the top, 1, 2, 3, 4, 5, and you have 9 x's in the bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9. The first x's cancel, 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 and what that remains with would be 4 x's all in the bottom. Our next slide covers the zero exponent rule. Remember, this is just a fact. Any number to the 0 power is 1. So 11 to the 0 power is 1. 5 to the 0 power is 1. This last problem is 12y to the 0, and it's quite tricky. Y is of course to the 0 power, but 12 has its own exponent, and that 12 exponent is understood to be 1. So this problem is actually 12 to the 1 times y to the 0. Now your rule for that is that 12 to the 1 is 12, and y to the 0 is 1, and 12 times 1 would give you the answer 12. That is the trickiest zero exponent rule that you would see. Our next problem deals with a quotient rule. Quotient to powers, actually. So you're going to take each term of the quotient and raise it to the exponent. So this first problem would x to the fourth divided by 2, all raised to the fifth power. You would have x to the fourth to the fifth power over 2 to the fifth power. Your rule for exponents here is your power rule that says if you raise a power to a power, you multiply. So this would give you x to the 20. On the bottom, you have 2 to the fifth, which is 2 one time, 2 times, 3 times, 4 times, 5 times. And 2 to the fifth would be 32. Our next problem is 2a to the fifth over b squared, all cubed. So this would be 2 to the third, a to the fifth to the third, and b squared to the third. So 2 to the third is 2 times 2 times 2, which is 8. So that would give me an 8. A to the fifth to the second, we multiply our exponents, and that would give me a to the 10th. B squared to the third would be b to the 6th. Okay, so I made a mistake with that one. Let's try it again. I miscopied. So let's see if we can fix that. You see where I said a to the fifth squared? That actually should have said a to the fifth cubed, and I miscopied that piece. So a to the fifth to the third would actually be a to the 15th. Let's erase that and start over. A to the 15th. Sorry about that. My final answer for this one is 8a to the 15th over b to the 6th. Our last problem is negative 3x squared over 7 to the second. So that's going to be negative 3 to the second, x squared to the second, over 7 to the second. Negative 3 to the second is negative 3 times negative 3, which would be 9. X squared squared would be x to the fourth, multiplying those exponents. And on the bottom, 7 squared is 49. And that's what we would get with those. That's our first group.